So sine and cosine, we're going to kind of have the same setup as we were working with tangent. ABC, this is just review from if you watched the video yesterday or looked at the notes yesterday. This was on there to start. To find sine and cosine, ABC is a right triangle where angle A is acute and angle B would be acute as well. The sine of A and the cosine of A, written as sine A or S-I-N-A, cosine of A, are defined as follows. It's not sin and cosine, it's sine and cosine. All right, don't say sin and cosine, sine and cosine. And they're defined as follows. To find the sine of A, you take the length of the leg opposite of A divided by the length of your hypotenuse. So just like we had the other day, our picture's already labeled for us. Opposite, leg opposite of A, over here. Hypotenuse is always your longest side, opposite of the right angle. So finding your sine, you divide the two. To find the cosine of A, you take the length of the leg adjacent to angle A, adjacent meaning next to. So this is our adjacent to A leg, and then divided by our hypotenuse. So if sine and cosine are both on your denominator, you'll have your hypotenuse. Kind of the mnemonic device that a lot of people use for your trig ratios is SO, ka, toa, where the S stands for sine, and then sine is the opposite over the hypotenuse. The ka part, that's cosine. And then to find cosine, you take your adjacent side divided by your hypotenuse. And your tangent ratio, or TAN, you find by taking your opposite side divided by your adjacent side. So SOHCAHTOA. I know there's another one, but I can't remember what it is right now. If you can remember this, it gets you a long way, because then you just have to kind of remember your algebra steps to solve. And again, a lot of this is done on the calculator since we don't know the sines of angles right off the top of our head. So, example 1. We're going to find the cosine and the sine and cosine of a 45-degree angle. So I always just like to keep it simple, start with sine, then do cosine. So the sine of a 45-degree angle would be equal to the opposite side divided by the hypotenuse. The side opposite of 45 degrees is 1. Our hypotenuse is square root of 2. So this is opposite over hypotenuse, if you want to write it. One kind of thing, I mentioned this, I think in, what was that, the start of this chapter, or chapter 8? We don't like having square roots on the bottom. So you can go through the process of rationalizing the denominator, where to get your square root out of the bottom, you multiply the numerator and the denominator by square root of 2. And what this does, it changes it. So we have the square root of 2 divided by the square root of 4. If we take the square root of 4, we get the square root of 2 over 2. So this is what we would call a kind of our simplified answer, square root of 2 over 2. You may be able to put this in for like on Big Ideas, a homework assignment. You may be able to put the square root on the bottom. I'm not sure. We can test it out. Otherwise, you got to go through and do this process. If it asks for an exact answer. If it doesn't ask for an exact answer, you could take 1 divided by the square root of 2. And maybe you can do that too. 1 divided by second square root of 2. If we were to approximate this, it'd be 0.7071. And that'll always be the sine of any 45-degree angle will always be 0.071. Because remember, trig ratios are constants. They are the same, they never change. So doing the cosine then of a 45-degree angle, we would take the adjacent side, over our hypotenuse. Well, the adjacent side is also 1. And our hypotenuse is still the square root of 2. So it's the same thing. The sine and the cosine of a 45-degree angle will always be the same. When you get to, if you move on to, like I said, algebra 2 with trig, or if you go into pre-calc, you'll talk about a thing called the unit circle, where you have kind of all of these with different degree measurements, and you'll have kind of, you'll see that in the unit circle, you always will say the sine of 45 is square root of 2 over 2, and the cosine of 45 is square root of 2 over 2 always. Again, this is one of our special right triangles as well. So we're going to do another special right triangle finding sine and cosine, but now we're doing a 30, 60, 90 triangle. So same process, keep it simple. I like to just do sine first. Sine of the 30-degree angle. That's my opposite side. So my opposite side is 1 divided by my hypotenuse. So that's 1 over 2. Or you can write it as 0.5. That one's easy. So the sine of 30 degrees is always 1/2, or 0.5. Cosine of a 30-degree angle. Our adjacent side is going to be the square root of 3 in this case. So we have the square root of 3. Our hypotenuse is still 2. So an exact answer would be square root of 3 over 2. If it was asking you to give a approximated answer, you could say 0.8660. That'd be your approximated answer for the cosine of 30 degrees. Yeah.
What is sine?
Sine and cosine, they're ratios that compare the length. Well, sine is a ratio that compares the length of your opposite side by the length of your hypotenuse.
But why would you need to do that?
Why would you need to do that? That's in engineering. There's a lot of sine and cosine going on. We're finding like the lengths, like building structures, things, finding kind of comparison between angles to find. Moving on, we'll say if I was going to give you 2 side lengths, could you then find the angle of this? So we'll build on more of how we're going to use this and kind of as we go through the chapter. This is just kind of like an introductory, how do you find it type stuff. This, in the kind of grand scheme of things, is probably one of the most used, when you think about how is math used in the real world. Probably trig ratios are kind of up there on the top of the list on things that are used. All right, I think we have one more example, a word problem. So you were skiing down a mountain with an altitude of 1,200 feet. So altitude, remember, altitude talk about is like the height of something in this case. The angle of depression is 21 degrees. Find the distance x you ski down the mountain to the nearest foot. All right, so we have this triangle here. Remember, angle of depression, I mentioned angle of depression versus angle of elevation on Monday. Depression, think of it, you're looking straight forward, but instead of going up, you're going down. So our down angle is 21 degrees. If we were to kind of separate this triangle onto off to the side, we'd have a 21 degree here, and X, our altitude is 1200. So to figure out what trig ratio you need to use, I would look at and say, what am I given? Well, I'm given an angle measurement. That's one thing I'll need. I'm given the side that is opposite of the 21 degrees, and I'm also given the hypotenuse. So then I think through my little hack to remember, is it so, is it ka, or is it toa? Well, I'm given opposite and hypotenuse, so I have to use my sine. So I say the sine of a 21 degree angle is equal to the length of our opposite side divided by the length of our hypotenuse, which we don't know right now. We just know that we're solving for it. From there, this is just like when we were solving tangent ratios, we have to solve for x. So to get x out of the bottom, you got to multiply both sides by x. So x times the sine of 21 degrees is equal to 1200. But then x isn't by itself yet. So I said on Monday you have to treat sine of 21 like it's a number. So when we're solving an equation, we can, divide by sine of 21 on both sides. Take sine of 21, because then this simplifies to 1. We're just left with x on our left-hand side. Sine of 21. So x is equal to, then you plug this all in your calculator, 1200 divided by, you just hit sine and then 21. And we would get, let's say how to round it to the nearest foot. If we were to approximate 3,348.5, so rounding it to the nearest foot, it would be 3,349 feet. You round it to the nearest foot. So one thing before you start working, remember, if you're using one of like a handheld calculator, it has to be in, just say degree mode or DEG mode. I know on some online calculators, if you use it on your Chromebook, it defaults to radians. So just make sure that it's switched, and if you don't know how to switch it, I can show you. All right,